Alrighty, we are live. Go for it.
Wonderful. So it gives me great pleasure to introduce Anita Graser. She's going to be talking to us about shaping open spatial data science. So just a brief introduction. Anita is a researcher, open source developer and author. She works at the Australian Institute of Technology in Vienna and teaches Python for QGIS at UniGIS Salzburg and serves on the QGIS Project Steering Committee. She's published several books about QGIS, including Learning QGIS and QGIS Map Design. In 2020, she was awarded the OSGEO's Soul Cats Award. And her latest project is Moving Pandas, a Python library for analysing movement data. You can find out more about her work on anitagraser.com and follow her on Twitter at underdarkgis and also now on Mastodon at underdarkgis@phosphodon.org. So just a quick reminder, please, we will have time for questions at the end. So please post your questions as Anita's doing a presentation to give us a bit of time to collate them. You're welcome to post them in the YouTube channel or the Matrix room. If you're in a local venue, feel free to jump on YouTube and do it that way. If you can't, then feel free to pass your question to the local chair and they'll pass it on to me and I'll collate them and ask them to Anita. Excellent. So I will hand over to Anita.
Okay, thank you so much for the kind introduction, Nick. Good morning, everyone. Greetings from Vienna, Austria. It's a real pleasure to be here with you today and to be able to talk a bit about spatial data science and what's going on and share some ideas, have some discussion later on. Spatial data science is a term that has been floating around for a couple of years now, and I think it's not so different from what we used to call like GI science, geoinformatics, all these things. Maybe the one addition that comes in with this kind of new term is this closer connection to explicit big data, AI, and ML that goes beyond the classic things that we always used to do in GI science, like remote imagery classification and object detection. So spatial data science in general is, for me, about gathering data, preparing it, massaging it, so that you can tell its story and present that story to others. So it's the whole process from data collection to presentation. And the key element that makes it spatial data science, of course, is that we are dealing with data that incorporates spatial and very often also temporal elements. So we try to turn this big spatial temporal data into insights, is what I want to say. And to do that, we need know-how and people, and usually interdisciplinary teams with a lot of different backgrounds. Of course, we need the GI science specialists who may have a background in ICT, geography, but also computer science, as well as the real hardcore computer science, maths, and statistics people who know AI, ML really well and who can help us include these new technology into GI science. Some of you may remember this slide from my last year's Phosphor-G presentation. Basically, what is the problem with open science in general? It's that a lot of things that we do in data science, of course, it's computer-based, so all the problems that can happen when we work with computers also apply to this data science approach. And the most common one, of course, is that a workflow might work fine for me, but no one else can reproduce it. So it works fine on my machine is really the issue I want to talk about still, because it is still unsolved for a lot of people. Also last year we had an excellent keynote from Silvana at Phos4G, who also talked about open science and who really stressed the multidimensionality of the whole problem, from open data, of course, which is needed to reproduce results, to the publications themselves, but also hardware, software, educational resources. So I strongly encourage you to check out the recording if you missed that last year. There are lots of ongoing efforts to make reproducibility and open science in general more commonplace. In the UK specifically, there's the Turing Way project, which aims to do open source, open collaboration, and community-driven open science. I really like the graphics that they developed on the right-hand side. You can see one of the examples, and I really like this core idea that they've written down in the bottom right of that graphics. It should be too easy not to do it. So you shouldn't have to think about whether you want to do open science, reproducible science at all. It should be so easy that it's an automatic given. It should make your work life easier, to do revisions for publications, to make your results more trustworthy. So that's the goal. I think we are not quite there yet, but it's a nice thing to have this vision. And I think it's helpful to think about the whole process that way. Other ongoing efforts, of course, are Open Science, Open Science. Both of those communities in their respective languages try to promote open and reproducible research by ensuring that the software that people use for data science is of good quality, is well documented. And then we have different journals, different conferences, for example, Agile, who have developed requirements for availability of code, of data, and for different policies of how to handle, how to encourage open science processes. And also, reproducibility is not just for academia. Obviously, that's where it's discussed a lot because of the reproducibility crisis that has been the talk of town for a couple of years already. But it's also very interesting, important in industry and government, because there we also want to have trustworthy results. So if we have a workflow that is reproducible, we can show it to other stakeholders, they can evaluate it, and just have more reliable results, better products, better decisions to work with. It's also easier to onboard new colleagues. So if teams change, you get new colleagues who should help you with your work. It's much easier to onboard them if your workflow is well documented, if the colleague can reproduce it on their own machine or from their own connection. So this also helps resilience and efficiency. It's also quicker to repeat analysis with new data. So ideally, the code is transferable, which would increase efficiency. And it's also easier to build on the previous work. So even if it's just yourself and you have to pick up what you did 2 years ago in a previous project because now you have a new one where you want to build on the previous results, you will find it much easier if you have a well reproducible setup in this case. So even if you're not in academia, I think the tools that are being developed in this context have the potential of also improving and making your work easier. The whole topic of reproducibility, it's really a spectrum, and no one can say, okay, this is not enough, this is perfect reproducibility. It's from just making code available, which is kind of a no-brainer for us in the open source community, to making code and data available, which is, of course, in geoscience always really important, because just with the code, but without data, you cannot really reproduce anything, to the ideal vision of having linked and executable code and data. Any place in between is a step forward, at least from the still standard publication only, dark side of the spectrum, going to really full replication, the gold standard, on the light side of the spectrum. Where's the place for phosphor G now on this whole gradient? I think the code side is very, very obvious. We have spatial analytics libraries in different languages in different states. Many of them part of OSGeo, of course, also many in related communities. OSGeo is also involved with the OGC to standardize data formats. It also provides the software to manage data exchange and to read and write all these different formats. So that's an important role that OSGeo and phosphor-G plays on this part. And on the more right-hand side, where we want to have linked executable code and data, I think that's where OSGeo could play a role in open science infrastructures, places where you actually get analytics as a service. These could or are already to some degree enabled by, of course, open source software, including OSGeo software. I already mentioned that conferences and journals, they already have policies, they have guidelines, they try to work towards this, making it easy enough, making it too easy not to do open science. So Agile, for example, has developed this checklist of minimum requirements for reproducible research. Or a computational workflow documentation in their research papers, and they also have recommended practices which often cite OSGeo and open source tools. So this is definitely a step in the direction, and it also acknowledges the importance of OSGeo and open source. What happened since the last phosphor-G? Well, I had one attempt at organizing a workshop at this year's Agile conference 2022, together with Vanessa, Sabine, and Anahit. We wanted to organize a workshop on movement data analytics, including in our goals to have all submissions be reproducible and replicable live papers. So we prepared examples of Jupyter notebooks for reading the example data sets, and we encouraged people to make their own contribution in a similar format and send those in. Unfortunately, due to confusions around the whole event and whether it would be restricted to on-site participation or whether remote participation would be possible, we didn't get enough submissions to really go through with the workshop. So I think it might be worth another try. Maybe we also scared people away with the requirement that they should submit their papers in that way. It's hard to tell because you don't really get feedback in that way if there's just not many submissions coming in. But I think this is still a way to go. Maybe we need to make it even easier so that people really, really want to contribute. So how can this reproducibility be made easier? I've been wrecking my head around that. Of course, on the technical side, we're always saying, we quite often hear that, yeah, just have a Docker container, it's perfect. Anyone can just run it from there, and installation of Python packages, everything is already taken care of. But in my experience, for many people, that is still not accessible enough. It's not a no-brainer for them. It's not too easy not to do. In the Earth observation community, I think there's been a trend to actually not work that much on your own computer locally. Of course, that one of the reasons is that the data that the people are working with is very large, so they are actively looking for ways to go into the cloud, and many of them went towards Google Earth Engine. We can think of Google Earth Engine whatever we want. Question for how long it will be available with Google's track record. But let's think a bit about that way, how we can have data in the cloud, how we can have workflows more easily available because it's more like plug and play. There is actually some players right now also in the Earth observation domain that are open source, and I want to show you two examples. One of them is the OPENEO platform. So you may know OpenEO already. It's an open source API for processing Earth observation data. And this platform, which is run by ESA, now provides these analytics as a service to the community. There are free trials and also early adopter accounts, which you can apply for if you want to work with the data on the infrastructure that ESA provides or this platform provides. And they explicitly target these pain points of making things simpler, to take away all the engineering know-how that people need to set up workflows, either for producing results or for reproducing results during paper review or other steps in the whole process. So they also talk about federation. So instead of working in our siloed environments, code should be reused. We don't want to reinvent the wheels. It's really in the open source mindset, which I think is very close to what OSGeo and Phosphor-G is about, to reuse. The other example, even more flexible, is C-Scale. It's another European focused project. Their goal is to make Copernicus data and tools more accessible to everyone. So they build upon the European Open Science Cloud portal and add this spatial data processing for Copernicus data on top of it. They also have Jupyter notebooks. They have OpenEO API to make it really easy to work with data and to create workflows. So again, ease of use is what they are targeting, what they're trying to make available for a wider audience. But what about other spatiotemporal big data sets? Earth observation is kind of a good place to start. First of all, you have a clear pain point to address because the data is so huge that no one wants to process it locally. Another big plus is that Copernicus data and similar sources are in general open data. There are no privacy concerns. There are no licensing costs that have to be taken care of. You can just offer it to people, make it available. With many other spatiotemporal data sources, that's just not the case. Things get more complicated. You might need to restrict who can access certain data sets. Also, there may be data sets where the designers of the platform are not completely familiar with all the details, because in Copernicus data, of course, the sensors and the characteristics are known. The designers of the platform, they knew about all those things. They could take it all into account. But if you build a general purpose spatiotemporal data processing platform, you may not know all the different types of data that different stakeholders will want to share, provide, and analyze. So this makes general purpose spatiotemporal big data analytics platforms really complicated to design and to set up well. And it's certainly a process. Right now, I'm personally involved in 2 projects who try to solve this challenge for the mobility data domain. One of them has already started. It's called MobiSpaces. You can find it under MobiSpaces EU and at the Twitter handle MobiSpaces. And we are trying to build a data platform for movement data, which is optimized, provides processing capabilities, visualization capabilities that are designed with movement data in mind. And I hope this project, which just started in September, so there is not many results yet, will nonetheless provide a first prototype of what such a platform could look like for movement data. And Emeralds is a similar project that will start in January. Key thing is both of these projects are already featuring projects, software pieces that are partially, some of them are already incubating in OSGeo. So MobilityDB is already a community project. MIOS, the mobility engine open source project, is related to MobilityDB. And also there's Moving Pandas, my project for movement data analysis, who will be who are participating in these EU project efforts. In general, I think on the technical side, the most promising path forward for me is to develop towards tools that are really easy to integrate different use cases and that avoid duplication of effort. So for reproducibility, we very often want to have notebooks that document our workflows and make them reproducible. Almost both of the platforms that I previously presented to you from the EO domain, they use notebooks. In addition to that, whenever we want to talk to stakeholders, people who maybe don't have a technical background, we may want to have some nice front end. So I think it's really key to develop solutions that make it possible without code duplication to have both the workflow and some rapid prototyping user interfaces, like you can see here in this example that I created for Moving Pandas, where you have the visualization of the stop detection algorithm on the right-hand side in a panel app, which is all coded directly in the notebook using the same functions that I use for the analysis of the data without having to write separate code to generate these things. So I would really encourage people to look closer into that. Obviously, I also hope that one day we will have notebooks in desktop GIS like QGIS, or the other way around, have QGIS output in notebooks, just to have all the power of the QGIS visualizations. In any way, I think there's still a lot to do. I want to circle back to last year's presentation. I think it's still hard to be a good open science citizen, but we are getting there, and I love to now hear your ideas, your comments, and to have a discussion. Thank you so much.
Wonderful. Thank you very much, Anita. That was a fascinating presentation. We've had a couple of questions already, so I'll get to those in a minute. Please do post your questions and we'll pass them back to Anita. So first of all, a question from Tom Chadwin. So I'll paste it in the chat as well. So we've got it written down. So he asks, when science is explicitly made reproducible, how often do third parties actually reproduce it? Or is it the effort of making it reproducible, enough for most audience to accept the results without reproducing them themselves? In other words, do people reproduce reproducible science, or do they just trust it more?
That's an excellent question, and the answer certainly is it depends. Ideally, of course, reviewers of papers should try to reproduce the results. So conferences like Agile have dedicated reviewers who try to reproduce the results presented in the papers. Similarly, journals are encouraging reviewers to try to reproduce the code that is submitted if they have such a policy. Obviously, not all reviewers can or want to do this extra work, which is still unpaid. So that's on the review side, still on the science side. Then, of course, readers of the paper might be interested in reproducing it, might be interested on building on it for their own work. So I think most people will not reproduce it just for the fun of it. They may try to reproduce it when they maybe suspect that there's something fishy. They certainly will want to reproduce it if they want to build on the findings of those people and maybe enhance them, compare their own approach against it. That's actually one of the points that I find most important, that as a scientist, you're always expected to compare yourself against certain baseline previously existing implementations. And in GI science so far, with most papers, that's really, really hard, because you have to re-implement the code from the description in the paper. And that just takes a lot of time. You're reinventing the wheel, you're probably making mistakes, and then you have other results. So this is where we are completely behind fields like classical machine learning, neural networks, where it's standard to publish your approaches, to make them available so that the next research group can build upon them.
Cool, great. Yeah, and there also seems to be an element of trust as well in terms of who's generating the code, and like you said, is there something fishy going on which might motivate people to actually try it out. We've got some more questions. I'm just trying to kind of collate them in a sensible way. So I'll do all three of them, and we can kind of discuss them together. So it's all to do with choice and standards. So hang on, it just disappeared on me. So Morgan Commons asks, what is the role of standards for advancing reproducibility? And then kind of on the other side of the fence, Al Graham says, although choice is good, is there too much diversity in the option for different open platforms, tools, and libraries? And that might mean commercial institutions just return to proprietary systems. And then Chris asked the question about transitional risk for corporations. So there's concerns about how the open source equivalent might be supported consistently. How could the wide open source community support the transition? I'll paste those in the chat so we have them for reference. So I think the first question is mainly about kind of standards and then choice as well. Is there too much choice, and how do standards play into that?
Right. So all excellent questions, many different aspects. I hope I can touch on all of them. Let me try. Regarding the standardization, I think there are already good efforts going on regarding standardizing access, like web processing, the OPENEO API. Those are things that go in the right direction, that make it clear whatever data you have. If you bring it into this format, you will be able to process them through the workflows, through the data pipelines on the platforms that are now being developed. Regarding too much choice, certainly. There's also the question again of complexity of different platforms. So, for example, from what I learned about these two platforms, OpenEO and Cscale, one of them, OpenEO, chose to have more like building block approach where you can use existing building blocks. You can have your own, you can write your own user-defined functions and work on the data. But it's still kind of restricted, and it's clearer what you can change and how still everything will work together nicely. Versus on the Cscale side, you can write your own custom code in any libraries that you want, and you push that towards the data, and that gives you much more flexibility, but also, of course, much more responsibility in handling the data, dealing with potential issues on data upload in the whole processing pipeline that you're creating. So yeah, choice is good. Sometimes you need more flexible options. Sometimes you need a certain library, some niche product, and it would be good if you can integrate that into the platform. On the other hand side, I can see how that might scare away users who just want something that is clearer for them to understand and to plug into it. So, but I don't really see how there is a huge difference necessarily between proprietary systems and open systems. They both face the same challenge, whether they want to be open and extensible and flexible, or whether they want to hold their users' hand and really give them nice little building blocks that always work. Of course, in both cases, you can think of how to support the users, be it proprietary or open. You can always have support. You can always have you should always have good documentation. So there, I think the playing field is really level. Of course, on the sustainability side, which I think was the last issue that was raised, that is the question of how do we finance that? How do we make the development sustainable, if I interpret it correctly? I think there we should align ourselves or find allies in parties like ESA, maybe other bodies in the European domain. They are really interested in setting up resources, infrastructure in a federated way, in a fair way. And to give scientists alternatives to those monopolies like Google Earth Engine, and to enable people to keep control of their own data, of their own code. So I think we as an open source community, we will not solve this problem alone, but if we can find allies in those organizations, that could be a really powerful way forward.
Wonderful. There was a lot in there, but it's kind of interrelated. But I think you managed to cover everything there. So thank you for that. Yeah, Chris, if we slightly missed a bit of your question, feel free to send it in again. So we got one other from Ian Turnton. I'm not quite sure if it's a question or not, but I'll read it out and see what you make of it. So if I use your code and your data, then it is really a reproduction of your results. If there's an error in your input data or in your routines, I can get the same wrong answer. I think economics had a recent issue with this and a badly formatted Excel spreadsheet.
Yes, I think if you're referring to the same example that I'm thinking of, it's actually not so recent anymore. I think it was related to the economic crash 2008. Actually, they only made the Excel sheet available on request much later, I think, when people were really trying to investigate how they came to those results, and then they found an error in the Excel sheet. So this is what I referred to before, like people will try to reproduce results when they think there's something fishy going on. Of course, if your results are plausible and people reproduce with your data and with your code, then they will might get the same potential wrong results, plausible wrong results. That's why, of course, also for scientific code, we should have tests. We should have good coverage, but we can never guarantee that software is bug-free. But it's the best effort. At least you can discover the mistake. Maybe if you try it with your own data, it will be more obvious that something is wrong because you have a different range of values or whatever. So you're absolutely right. If the results are plausible, it might not be so easy to identify that there's an issue.
Cool. Wonderful. Great. Thank you very much, Anita. And we've had a few thank yous. So Tom and Chris both said thank you very much. So I think we did really well with the questions. I'm going to draw this to a close now, I think. So yeah, thank you very much, Anita. We had some round of applause from somewhere. I just heard it.
Thanks so much. Thank you for all the questions and have a good day.
Thank you very much. Please do, feel free to post questions in the matrix room and we can pick those up later on. We're now going to move on to Tim Sutton's keynote presentation. So I see Tim's here. I think, Amy, you've got a little bit of admin to do.